Hello, all of you. So today we'll start with a new topic that is cloud computing technologies. So here the technologies involved are like SAS, inexpensive storage, some of the CPU bandwidths support that is required for the client, some of the significant algorithms like of HTML, CSS, AJAX, so client broadband, SOA, and there are many large scale implementation and providers are there like of Google, Yahoo, Amazon, and other companies for massive scalable distributed computing. Then commercial virtualizations are there. Then cloud computing is one of the upgraded version of grid and utility computing. Thereafter, you need to know that these cloud has been evolved for addressing some of the internet issues like quality of services, some reliability issues in the internet technologies, and all these tools and technologies are being built for the data and compute intensive parallel applications. And some of the technologies that you might already heard about is supercomputers, grid computing, utility computing, then pay as you go model is there, illusion of infinite resources are there, demand billings are there. Billing could be done based upon hourly, daily, and number of users basis. And software as a service SaaS could be based upon hardware, platform, and software. So thereafter, virtualization and services. So virtualization basically means illusion of infinite resources and devices that are being connected, and low configuration virtual devices are there that are easy to be managed. Then service oriented architecture like uh, cloud computing adopts some concept of SOA that have services which solve sub problems, and these sub problems and services are being integrated to solve larger problems. Furthermore, the service are being divided into individual operations. Operations are like just like procedures in the whole Java programming. And cloud computing are basically uh, based upon the existing technologies. So what are these two existing technologies just that we discussed? One is virtualization and one is service oriented architecture. So these are the two existing technologies and knowledge which are being used by the cloud computing. So the cloud computing provides its resources. So it establishes SOA virtualization and globalized user-friendly technologies. The mainframe computers are there, means other in the old time. So mainframe computers were there, which actually are very powerful computer. Critical bulk data processing happens over there. Peer-to-peer communication devices are there for distributed architecture, central coordination, participants of both supplier and consumer resources. Client and server architecture models are there. Then grid computing is basically is a kind of composed of cluster network devices, and networks are being acting on the converged resources. Utility computing are there, which are having computing resources, CPU and storage are there, then charged according to pay as you go model. Then service oriented computing is being organized and utilized based upon the distributed service offered by the different owners. It is formal way of discovering and interacting with the feasibility and orchestration according to the requirement. So the peer-to-peer computing is being changed to grid computing. Then grid computing is being changed to utility computing. Then utility computing is being changed to service-oriented computing or SaaS. Then cloud computing. Thereafter, we'll discuss hardware and software infrastructure. So we are not talking about tens of CPU. We are not talking about hundreds of CPU. We are talking about hundreds of thousands of CPU working together, which is having many number of CPU boxes, many number of terabytes of hard disk, huge RAM, and there are more than thousands of CPUs are there, and there are actually each cluster have such thousands and hundreds of nodes working together. So can we develop such lab for practicing? Yes, if you can install Eucalyptus in a small machine, OpenStack, you can install OpenNebula, Nimbus, these type of cloud middlewares. If you can install, then you can realize cloud in the small machine itself. Then can you develop Google app, means deploying some application on Google application, Google website? Yes, it's possible. You can develop your own web application and deploy it on Google App Engine with the help of Google Web Toolkit. We'll discuss this in later part. Then we can develop some application on Google App Engine. Similarly, we can have Ruby on Rails and which works on Engine Yard. Thereafter, there are Hadoop and Storm like middleware that you can install in your machines. The service-oriented computings are there, grid clusters are there, then many more things are there. Then thereafter, data centers. Data centers is basically a house of computing systems associated with components such as a telecommunication and storage system. This includes power backup and supply for the redundancy of the data, communication connections, environmental controls are there, air conditionings are there, fire suppressions are there. So various security devices are there. Large data centers are industrial scale operations using as much as electricity as a small town. So data center uses very large amount of electricity. They need cooling systems. They need power backups. They need very large size of communication systems. Then the cloud engines are basically Eucalyptus, OpenStack, Nimbus, OpenNebula. Web services are basically interoperable machine-to-machine communication, which which works over network with WSTL and SOA messages. Thereafter, we this web services takes place communication takes place on HTTP and XML standards. So WSTL is a description of web service XML, and SOA is the packet of message in the XML. Thereafter, in the hypervisor virtualization, a VM is a software which would be implemented on the machine and or a computer that can execute in the program like a physical machine. So the hypervisor is just a uniform abstraction, and hypervisor is of two types: bare metal and hosted one. In the bare metal, it runs directly on the hardware, and in top of that hardware you install hypervisors. And what type of hypervisor? Bare metal hypervisor, that the OS is being loaded. An example of such bare metal hypervisor are Microsoft Hyper-V, Critics, Zen servers. And then the type 2 is basically hypervisor runs on guest OS like KVM. So there are two type of hypervisor. One is bare metal, which actually directly deploys on the hardware, and hosted one, which actually deploys on the operating system. Then the keyword big data is also related to cloud computing. There are two types of big data. One is batch processing, and second one is real-time stream processing. The Google file system and Hadoop distributed file system are used for the batch processing. Then Storm is being used for the real-time stream processing. Thereafter, in the next part, we'll discuss about the different clouds. So thanks for the listening to this presentation.